I'm going to bring your screen here and let you take it away.
Yeah, I had a hackathon FOMO, so I really wanted to participate, but obviously I can't as a judge. But ended up building a little bit of a project and maybe a practical walkthrough to hook everything together. So we had people start talking about the vaults, and that is maybe the first piece of the Legos. And then this is the piece that would connect to it. So you can have kind of really sophisticated mechanisms to decide how you give away the funds that you generate. And one of them that I think will be popular is NFT-gated voting. So I figured I would show how that works in our system. As you guys have seen by now, there's a little bit of magic in all of the Octant branding. And we want to bring that into the development experience as well. So quadratic voting is a pretty simple mechanism where the cost of casting a certain vote weight is the square of that the vote that you want to cast. So if you wanted to vote 10 units for something, it would cost you 100 voting power. This usually translates to money, but you can use quadratic voting without having people put in funds. And this is the simplest form of governance that I think we can implement on Octant, because we have simplified it to the point where all you have to do is tell the contract how you would like to control who can vote. And everything else is kind of configured for you under the hood. I'm going to walk through a few examples of doing this with NFTs, go through a couple of the pitfalls that you probably want to avoid, and hopefully along the way you can see how easy it is to implement one of these in our protocol. High-level architecture review. So this follows kind of the same pattern that Maxime talked about earlier from Urine, which is all of the complicated pieces of the mechanisms are handled in these tokenized contracts that have calls delegated to them. And so this is a kind of new primitive that allows you to not think about how the voting happens, and exposes several hooks in order to configure how the behavior should change between different implementations. So we are going to take this base allocation mechanism, which you don't need to understand or ever touch, the tokenized allocation mechanism, and a quadratic voting mechanism, which are all contracts you can find in our repo. And we're going to inherit from them to create an NFT-gated QV mechanism in a few lines of code. So the hook system that we open up has 12 customizable hooks that allow you to change the behavior of how the voting system functions without rewriting any of the core logic. So we've spent a lot of time and money securing the contracts. They've been audited, and you kind of inherit some of that security by signing up. However, the core functionality is still defined by the authors. So we've opened these 12 places that you can put, we think, very small bits of code in order to make a big impact into how things are implemented. In this example, all that you have to worry about is modifying the before sign-up hook and the voting power hook. And this will allow us to create a mechanism that does quadratic voting for people that hold NFTs. This is kind of what an example deployment would look like. So you create a new contract and inherit our contract. And you'd have to pass this allocation config, which defines some of the primitives that you need to configure our mechanisms. And then the only lines you'd have to code up is this before sign-up hook. So we'll start with the naive implementation. This simply checks if the person has signed up already and whether they have that NFT at all. And if so, it returns true and all checks pass. And getVotingPower hook This is the second option. We're going to make it so that everyone has a fixed amount of voting power to keep things simple. So regardless of who signs up, so long as they pass that previous hook, they will receive a fixed amount of voting power. Alternatively, you could gate it by giving different people different amounts of voting power, depending on their balance, or even make it proportional to their balance. But let's keep it simple. And this is pretty much everything that you need to implement to get the NFT gated QV mechanism. So that's it, we're done. Except for all the things that you get for free. So all of these user actions and proposal management and view functions are part of our API or ABI for the smart contracts that you can call in order to manage voting. And it lines up to an end-to-end flow for voting that includes signing up, proposal management. So this is defining who the projects that people can vote on are, or the initiatives that things will be split. The voting. So in this example, Alice can cast a vote and we do the whole quadratic stuff under the hood for you, as well as this very interesting parameter called set alpha. And alpha, which I'll go over now, is a way to tune how you want the voting tally to happen. There's a few more steps as well to finalize the vote, and then queue and redeem, which all happens trustlessly. The idea here is that eventually, when you get all these Lego blocks and you line them all up, right, you got some of our partners and they have sources of yield, you get a yield donating strategy, and now this means that people can deploy funds into these smart contracts that trustlessly donate money to something like an allocation mechanism or regen staker, or a community fund of some kind. And eventually, if you hook it up to an allocation mechanism, the entire flow from funds being generated to the projects receiving funds becomes completely trustless. And this is the high-level vision that we want to achieve, but we want to make it as easy as possible for you to configure things. So we expose this contract called proper quadratic funding, and it follows some moon math that is managed by this alpha. And I'm not going to go over the math. It's not super important, although we'll put resources in the Discord and Telegrams that people can reference in order to dive in if they would like to modify it. But the important thing to understand is this alpha parameter. So by simply setting alpha, if you set alpha at 0, you end up with pure linear voting. So this could be something, if you're implementing token weighted voting, you would want to set alpha at 0. And this would make the contracts act exactly the way that you would expect, where one vote is not matched in any way. If you wanted to do pure quadratic voting, then you would set alpha to 1. And this makes the linear term disappear and now makes the funding amounts proportional to this quadratic function that we talked about. And if you had a fixed matching pool and you wanted people to pay for their votes, you would set alpha between 0 and 1, depending on how many matching funds you have. And this is what people call QF. So there's a lot of like mysticism and moon math about how it should be implemented. We've kind of abstracted all of that out into this knob, which is alpha. And depending on how you want to tune your governance, you could make something more quadratic to have a broad consensus, or more linear to line up more with token weight or the way that you assign votes with the previous hooks. So all of these things together give you a pretty tunable environment. But even so, there are security considerations that you should consider while you are building. So I wish I could have put that Lord of the Rings meme of one does not simply create a tokenized allocation mechanism. If someone in the marketing team could whip that up. the security considerations still mean that you have a lot of power to do things in the system, but you need to be very careful about the balance that you strike, especially for voting, because there's nuances that you have to consider that might not be smart contract security solidity bugs, but game theory bugs. So a big one is handling Sybil attacks. So if you have an NFT-gated system, like the one that we built before, excuse me, even though it sounds pretty nice, it's vulnerable to a pretty simple problem where if someone borrows an NFT, they can sign up, get some voting power, return the NFT to the owner. Maybe the owner lends it to Bob, and using the same NFT, they sign up again. And you end up with a problem where there could be some Sybil spam in your voting round. So you don't want that in terms of game theory. You'd ideally like one person to equal one sign up when people vote. And so the solution is to require, or the proper architecture rather, would be to require either a soul-bound NFT, and this is something that essentially is not transferable, so that you know it can only be used once, and then you can mark it off, or an ERC20 votes, ERC 721 votes mechanism, where you can use an Open Zeppelin standard in order to checkpoint how many votes someone has, and this gives you the added benefit of delegation. So what is ERC 721 votes delegation pattern? This is a pretty simple contract that is an NFT, but like ERC20 votes, allows you to decide who has voting power at a certain period of time, and then use that in order to attach to other governance mechanisms. Our tokenized allocation mechanisms are compatible with that paradigm. An important thing to note here is that ownership does not equal voting power. So you could have Alice that owns some NFT, let's say number 42, and her balance is 1. But if you check her votes, it might say 0. And this is because voting is separate from ownership. So Alice can call delegate and decide who she gives her votes to. She can assign them to herself, or she can assign them to Bob. And then when they sign up to our tokenized allocation mechanism, you could check that and see if they've already signed up, or see how many votes you should give them. And this is an example of what that would look like. So as you can see, the implementation is really simple. This is like essentially the full contract, and everything else is pipe work and getting it deployed, as Austin just showed us. That in itself is not super easy either, but the actual amount of code that you have to write in Solidity in order to get this up and running is very minimal. So if you don't have a lot of experience, this is maybe a good jumping point to get your feet wet in Solidity, and will be available throughout the week for anyone that needs help. I wanted to leave you with a comparison behind different NFT gating patterns. Again, you should really think through how you want your voting to happen before you start building. So if you're doing soul-bound NFTs, you're going to check the balance. If you're using ERC 721 votes, you're going to use get votes. If you have something more bespoke, for example, if you look at the nouns contracts, they have a different function called get current votes for user. So there is different trade-offs here depending on what community you want to serve, and you should check what their implementation looks like before you dive too deep into building. I will leave you with some extra use cases that I've thought up that I think would be cool to see. So tiered NFT power, token gated access from an ERC20 or ERC20 votes, simple whitelist, or some reputation integrations, which there are a few of. So there's a lot of really cool low-hanging fruit to develop that we'd love to see in the contract, and some development tips for when you're doing things. There are different voting periods that you're going to want to flip between. If you are in Foundry, remember to warp and not roll. You want to use absolute timestamps. This will save you some heartache when you are testing. Have some key resources, and I'm debating whether or not I should publish the the code because I might have done a little too much already. But I will keep the presentation short since we are towards the end of the day, and thank you for everyone still watching. If you have any questions, I'm looking at Twitter.
That was fantastic. Thank you, Mud. Appreciate the workshop here. Very, very exhaustive, very cool use case to be combined as part of everything we're doing at Octant. So that was very cool to see. For anyone who has questions, please drop them in the chat here on X. We'll be here for a few more minutes to answer any questions. But in the meantime, Mad, are there any specific ideas or things you'd like to see in the hackathon, or you'd be excited about?
Yeah, this is maybe the lowest hanging fruit, where you only have to add maybe 5 or 6 lines of code to get a full voting mechanism. But if you dive more into our docs, you'll see there's a lot more configuration that you can add to implement new voting strategies. So we have quadratic voting, funding, and linear voting out of the box. It would be cool to see different strategies, or how this hooks up to a vault or something to that effect.
Nice, very cool. And have you also been to hackathons? Are you a hackathon
Yeah, I have some
enthusiast?
strong
Yeah.
opinions about hackathons.
Oh,
I think that you always want a designer. It's never led me wrong. Having like someone who is more artistically inclined and oftentimes a really good communicator is a really big bonus, so that while you're building, someone else can be honing the pitch for it. And oftentimes having that person that is maybe thinking one level up, or how it's going to look to someone that's using it, is really helpful when you want to iterate quickly.
yeah, absolutely. I think it's more clear now that we're seeing all these, let's say, hackathon projects shine, that this become really crucial to differentiate yourself from your competition at the hackathon. If you can tell the story, or show an application that's also visually compelling, that always helps and earns a lot of extra points, and also helps the technical side be more digestible and understandable for people who might not have been with you in the entire process. So totally agree with you.
Yep. And we're going to be in Discord and in Telegram the whole week. Do use the mentoring sessions, and maybe we should talk about the check-ins.
Yes, that's actually what I wanted to do next. I see Croncut asked, what should we do in check-in and two? The check-ins are basically just an opportunity, but at least one of them is mandatory for each hacking team to ask a question, and just really, as the name says, check in, like say, hey, I'm here, I'm hacking. Now with all these cool AI features that we see. I mean, we've seen Austin walk us through almost vibe coded application, which is awesome. We love to embrace that. But the downside of that is that there's a lot of applications that have like zero effort, and there's no thought process behind it, and maybe just using AI to submit it, and for the hope that they get a price. So in order to avoid this, we want to do check-ins so that we know there's a real team behind it, a real person behind it, and also use it as an opportunity to ask a question, ask if the hack is going in the right direction, or just in general a touch point with teams and mentors. Aside from this, in the hacker manual, you'll be able to book a time with a mentor you're assigned. You will see which mentor is assigned to you based on the first letter of your last name, basically. So go to the hacker manual, and you will see the links to book a time with your mentors there. And yeah, we will send you more. You can see in the folio schedule when the check-ins are scheduled. So you will find the links to join and the instructions to join there, and we'll also, of course, be communicating that in the Discord and Telegram channels. Is there anything else you wanted to add, Mud?
No, excited to see everyone come in, and excited to help the hackers put something cool together.
Yes, we've had more than 1,500 people in this live stream, which is amazing. I did not expect to have so many of us here. So yeah, I'm really excited to see all the different hacks that are gonna come out of this. We also have a bunch of signups in the for the hackathon right now. If you would just joined and would like to sign up, I'm sending the link in the chat here. 1 second. There we go. It's octant.thefolio.co. You can sign up to the hackathon there. You will find all the relevant links there and all the relevant information for the hackathon there, and also including a link to the hacker manual. But also feel free to join the Telegram group chat or Discord and ask your questions there. We can, of course, point you in the right direction, but anything related to the hackathon should be available there in the folio and the hacker manual. And maybe one last final update, Mud. Is the repo already available for the hackers to dive into it?
The repo is freshly available as of this morning to dive in. The docs are updated with all the smart contract ABIs if you'd rather read from your phone, or the Telegram chats and Discord channels are also manned. So we are ready and excited to see people start hacking.
Let's go. Nice. And of course, this is also our first hackathon. Our docs and repos and everything are just fresh out of the oven. So please do send us feedback if there's anything that is not clear. Also in the hacker docs or whatever, please do send us feedback. We're of course very open to hear that and improve as we go. We want to make the best experience for you, all our hackers. To really make this an impactful thing. I think there were a lot of comments from our speakers throughout the day about thinking, let's say, more long-term and like making a project that is actually meaningful. And the design of this hackathon, how we set up this hackathon, is actually also meant to do that. We really want to take everything that you build seriously, and we want to experiment and see how your different builds would play out in a real world setting with Octant v2. For those who don't know, Octant v2 is meant to be used for generating yield and using that yield to fund and grow ecosystems. So the target group to use these are basically DAOs, foundations, treasuries to grow their ecosystem. So having that in mind really build something meaningful. And if you do it correctly, you do it in a clean way, and show us your thought process behind it, I'm pretty sure it's going to be implemented and used, and would love to see that. All right. So yeah, we're coming to the end of the DeFi Devs Day. I want to thank everyone for coming and sharing your knowledge and workshops with us. Thank you, Matt, for closing this this amazing day with me. And yeah, just wish you a great hackathon week and a bit more. And excited to see your projects. Any final words from your side, Matt?
No, let's get hacking, and happy Friday, everyone.
Happy Friday. We'll see you in the chats. Have a good one.
Cheers.
Bye bye. Cheers.